The clock is ticking. The guys have to get lockjaw to the sheet metal shop by July 1st. In this episode, Eric laser scans the bed while Matt designs the reverse opening hood hinges. Binks Built, protected by Amsoil, with support from Roadster Shop and Nitto.
So before we go in and actually start cutting things up, Matt and I have been looking at guys who have done similar things in the past of, chopping up a lot of these beds and the cross members and slats and tubs and everything and reworking them to fit huge tires and different frames, but ours is a little more unique in the fact that it's going to end up getting split and going to be a dump bed with actuators underneath to do so. But
very unique, I would say.
Yes.
Yeah.
And even just to get it on the chassis, a lot of this has to come out, the big one being the tubs. So those carriage bolts, there's no way those things are gonna spin nicely, so those will probably end up having to get cut. I think the inside seam is, so this is bolted, so we'll be able to pull these off in one piece.
Anyone who's ever restored a bed before probably knows that this is the worst part of the job, is getting all these carriage bolts out.
Just the 6 that were housing it to the frame were a pain in the ass. So there's going to be a lot for these original slats, considering we kind of just hammered the wood out and destroyed what was in here.
That's going to be fun. We get to design the whole
hinge system,
engine system to get to pick this at the split here, to pick this whole thing up. Actually the tailgate's over there, so to lift it up and take it off that way. If we scan it and put it in CAD, we've got the whole chassis in CAD, so
and then
we can do a lot. We can do a lot there. And
the big thing here, Jay and I touched on it a little bit, is you keep this thing structurally sound and not having a bunch of deflection under articulation. Because even as it sits now, it's pretty flimsy. So I've seen some guys do their own cross members, and that works great for a standard bed where you're just putting stuff in it. But something that's going to be articulating as its own piece with hinges out back, it needs some sort of triangulation into itself. So that's going to be a fun challenge, I think, to figure out how to not only attach it to the sheet metal, but design the whole skeleton, so to speak, for this guy. So that'll be the big continuation once we get this thing fit up and take a look at our space limitations for what we have. And
so first thing we need to do is get all this junk out of here.
Yeah, it's become the parts bin as we're working through the cab. So I guess we ought to start there.
All right. All right, so we heard from Gail about designing the whole air system in the front, how it's going to come through the radiator, the charge air cooler, the condenser, and then off to the side we're going to have our filter set up, and we're going to bring that up into the supercharger inlet. Now, in order to do that to the degree of accuracy that Gail wants to see, we need to bring all of this sheet metal data into CAD. So we've got the engine in there already, we've got the chassis in CAD already, so What we're doing now is using our handheld laser scanner. We positioned reflective dots all over the sheet metal and all over the chassis to help the scanner pinpoint itself and know its spatial location. And so we're going to scan this, bring it into CAD, then I can position each of the individual components, the filter, the supercharger drive and inlet, and connect all those parts and design all of the ancillary stuff that's going to go along with it. In order to use the scan data after we've gotten it into the laptop, we've post-processed it, then I'm going to bring it into CAD, and in order to make it usable and make my life easier, we're going to use some existing points like our Banks high flow manifold here. We'll use the rear surface as a datum and some of the contours to help line this up. We'll use some of the Roadster Shop chassis points on here. So this is a flat plane that I can use to align everything in CAD and bring in our firewall. We'll actually scan these tires and we'll put them at full compression, and then we'll take them lock to lock also. So I get full rotation of the suspension, full compression, and we can bring our exhaust around the tire. We can bring our inlet up into the supercharger. All right, so we've laser scanned the front end of Lockjaw now. We got the hood and we got the front sheet metal and the grille and the bumper. And we separated the hood CAD or the hood scan from the sheet metal CAD, and I'll show you why in just a minute. Because what I've done now is decided to design some hood hinges, reverse opening hood hinges, rather than just buy some off the shelf. We're gonna make them, which has been challenging. I've never designed hood hinges before, but we're always up for a good challenge.
And this is 6 bar as opposed to 4 bar?
So we need the 6 bar action to get tilt in the hood, but we need 4 bar action to get the hood to lift up without hitting the sheet metal that's in front of it.
And then, yeah, close with those corners.
So the 6 bar, yeah, so the 6 bar kind of does both. If you set it up correctly, it picks the hood up and then starts to rotate it. So we can come away from the front sheet metal and then tilt up over it and have access to the engine compartment, our Whipple blower, be able to do any maintenance or be able to gawk at it when we've got it at shows. So let's take a look at this. A 6 bar linkage, aptly named, consists of 6 bars. I've got them color coded here so that you can see what's going on. The one that you don't see is this is the mounting point. So this will be mounted to the core support via some bracket that we're going to fabricate. I haven't designed that yet, but that is considered bar number 1. And then 2, 3, 4, 5, 6. So our hood is going to mount up here. So let me quickly show you what happens when this linkage actuates. And there is 65 degrees of hood opening that we've got. And now let's close that again, just close the hood.
So were you able to mate up the scan to these mounting points and the hood hinges to where we could see it manipulated?
It's exactly right. So we've got the front end scan in one, we've got the hood scan in another, and I set it up so that we can actually open the scanned hood, which is pretty cool. So let's take a look at that. All right, so in this model, I've got Lockjaw's engine, transmission, chassis, some tires in each direction, and then the laser scan that we did. So in this brown color, which is representative of our lovely paint on Lockjaw, we've got the front sheet metal, and then in blue here, I've got the hood. We just saw what happens with the hinges as we open them.
And is this the inner skin of the hood? I noticed it looks a little short.
It is, yeah. We scanned the underside of the hood so that we could grab all the brace points to be able to, we got to make brackets for these hood hinges to grab on the underside and pick it up.
So I've seen on like the fancy billet replacement hinges, they'll do like a shock actuator type setup. What's the plan for this guy? Are we going to run some sort of assist on it?
I'm kind of an old school guy, so what I'd like to do is kind of pay tribute in a way to all of the beautiful hood hinge designs of the past and use an over center spring.
Just like the stock one.
Just like the stock one.
Old school mixed with new school.
So we got the underside of the hood here, And forgive what happens to the graphics here while I manipulate this, but let's zoom in here and pick this hood up. So you can see over here we've got our 6-bar linkage under here. This is a lot of graphical data for the computer, so it kind of goes black while I do this, but we can watch it open. There's 5 degrees.
That's so cool.
So there we've got it open 10 degrees. You can see how it picked up away from the front sheet metal here, how the linkage is starting to expand. It's important to not have any of these links here go what's called over center, or the linkage may bind on
Or
you.
fold back into itself.
Fold back into itself and then lock up, and then that's a big pain. So when we make these, we'll actually make some physical stops so it can't over center itself.
Forces it one direction.
Yep. So we're at 10 degrees right now, and I'm going to zoom out a little bit so we can see what's going on a little better. 15, 25, and you can see the front edge of the hood
Yeah, it's going
picking up away from the front sheet metal.
Going way out there and away from all that.
30 degrees, 45 degrees, 50, and now watch these two links right here. We're at 50 degrees, 55, 60 degrees, and at 65 degrees is right when those two links are going to start to over center. So that's where we'll build our stop. We'll limit the hood opening to 65 degrees. And Bob's your uncle. So we'll probably end up on this link here with a spring assist that when we're open has a moment arm out this way with the spring pulling down. And as that link closes back up, it'll swing past this center point, the rotational point of that link, and the force vector will be back in line or very close to in line with the rotation point of the link. Almost no force exerted when it's closed. As it starts to rotate, moment arm increases, pulls down on it, holds hood up.
Love it.
There we go.
Easier said than done, though. That is so, and it's pretty far away enough from the engine bay to where you're gonna still have plenty of space to get in there.
You can see this is our radiator right here. Supercharger inlet, I'm almost finished with the CAD on that. And then if we look here,
way out in front.
yeah,
That's
we got to
awesome.
look at it from a different angle. So we look at it from this angle, and we can see here.
Okay, right off the flange of that fender.
Yeah, so
and
right
in front of the core
here
support.
is the core support.
Yeah.
So I've positioned these to be right behind the core support. So we can grab this area right here with some bracket coming over or up and triangulate it, and then come straight down with that spring into this kind of dead zone that we've got right here. Utilize that space, because over here, big ass filters.
Yeah, so it'll be right behind the headlight and in front of the tub to where it's pretty much the only spot we're gonna have left in this thing.
There we go. Now we got to make them.
Okay, so we've got this thing back on the ground. Jack stands are off. We shimmed the front-ish to kind of get it to lay level how we want. Everything is still kind of loose at the moment, but we just want to get it in position and kind of get an idea of what we're up against. So Matt brought up a good point in that the drive shaft, as it sits, the drive shaft would run right into these U-channels. So what I've seen looking into this is a lot of guys will remake these U-channels and they'll do their own, fancy laser cut cross brace. But in our scenario, I'm not sure that that's going to work. I mean, at the least, we'll have to notch it over, between the frame rails, so we just have more room.
Well, we've got some interesting stuff going on that a lot of other people don't.
Exactly.
Which is that at this body line here is where we're splitting. So that's roughly, and we'll scan this, we'll put it in the CAD, and we'll see exactly where all that lines up. But it's roughly going to be around the notch and where the shock mount is. So we end up, and we're going to put the floor at that level, right?
Yeah.
Right. So we're going to end up with a bed floor here.
Up.
So we'll be high up, and then we end up with all this space. But when we open this bed,
It's exposed.
then we want everything exposed and pretty, and show trucky.
Well, I guess exposed,
That's a word, right?
Sure,
Yeah.
sure. If it's not, it is now.
Yeah, we can get a drive shaft mocked into this thing here pretty soon. We'll have to chop the
Yeah, go through
the
now
cross
that
members
our
with-
yoke is pretty much crashing into the cab as it sits.
Yeah, so we'll cut some more on the cab floor. We'll notch the back of the cab, and we'll notch the front of the bed. And then this is going to be our highest point, right? If this is like full upward drive shaft travel right now, since we're currently on the ground with our frame.
Yeah, that, and then I think our final tire is going to end up a little taller to where I think it was about a 1/4 inch off this top lip. So we've got more tire to deal with, but
Yep.
I think the scan here
And
is going to be...
some stake pockets and stuff like that get pretty tight
Hopefully,
in here.
yeah, hopefully it doesn't get too much wider, but
Yeah.
I think the scan's going to be a huge help so we can start getting an idea of, you know, our space claim for all this stuff, and instead of getting here with a tape measure and eyeballing it and saying, oh yeah, we got
Yeah.
4 inches
Yeah,
of room for
well,
this
you know,
piece. And
we got the tools. Let's use them.
All right, so yesterday we've got, or I might hurt my shoulder a little bit, put about a couple thousand stickers on this truck bed here, and we're gonna get it scanned up today. So first things first, I gotta get this thing calibrated. But when it comes to doing big scans like this, it's best to try to merge it all into one big scan. If I did a bunch of little scans and tried to merge them in post-processing, I run the risk of having little dimensional accuracies, and for something like this where we're trying to get locating positions and, you know, get it really accurate to our chassis, I don't want to take that risk. So first thing we got to do is pop out this calibrating plate. So what this guy is essentially a pre-made sheet with targets already on there that we then cross-reference to the scanning software, and it calibrates it before a scan. Calibration, and it'll actually walk you through in 3D of how to position your scanner and get it set up here. So it's like a little video game. All right, that's all there is to it. And we are ready to scan. Cool thing about the dots is if I get to an area and I notice it's having trouble picking up a certain spot, there's a good chance that I don't have enough dots in that area, so you can always add them in during the scan. Look at those dents. You can see it so much better in the scan than you can on the actual truck. That's trippy. All right, let me get you guys up to speed. So I just finished doing the inside skin here. We already finished the outside, and I purposely overlapped all these top surfaces so that I can hit this merge scan feature, and what that's gonna do is align these on the same origin using overlapping features like that. Fingers crossed. Okay, so I'm gonna do my best to explain this. Now I have both scans smoothed, and I have them in the merge section now. So what I did is I merged them based on all these positioning targets. So all these little dots is my defining feature for the merge, and everything you see here in red are overlapping points. So what it's taking, like I anticipated, was on both scans of the outer and inner skin, I went and got that overlap on the top of the bed, and it's picking up the same points. And so what it's doing in here is using those same points to align itself. And you can see all these red points have got it, and in these overlapping sections, you can see that they're in the same space, so they're aligned correctly. So now that we got the pink, that's the inner, blue, that's outer, and once I go ahead and align these and merge them, we'll have one singular STL file that we then bring into CAD and use as our master reference. This thing is going to be a lot easier to split in CAD than it is in real life, that's for sure. SoCal summers are brutal in the shop. Gotta get some big ass fans in here. These little guys don't always cut it.
In the next episode, Willwood stops by with some big ass brakes.
Oh man. Wow, you guys do have a lot of work to do on this thing.